3.10, determining differentiability from a graph. So what is this big long word, differentiability? Well, it's where the derivative is undefined. So the derivative, remember, is a slope at an instant, at a specific point. So it's where we can't actually find the slope at that point. In other words, there we go. In other words, where the slope at a particular x value doesn't exist. A function is not differentiable when there is, we talked about this on the last lesson, a sharp point, which is a corner or a cusp, because the slopes coming from the left and the right are different. A vertical tangent line, so remember vertical lines have undefined slope, and where there's a discontinuity. So remember we talked about when there's jumps, when there's holes, when there's asymptotes. Those are all the types of discontinuities. So put holes, jumps, or vertical asymptote. So let's try some. Number one says use the graph of the function f of x shown below in order to determine all values of x in the interval from -9 to 9 where the function is not differentiable. So follow it here. We can't use the endpoint. Here at -7 would be a problem because there's a jump. So it's not continuous there. So we would say at x equals -7, we'd keep going, kind of flatten out here, but that's okay because that's just a slope of 0. Keep going. Well, I see here at -3 is where we change concavity, so we'd have a vertical tangent line there, which is undefined, so that would be at -3. We flatten out, which is okay. And then we come to an asymptote here at 2. So that is one type of discontinuity. So 2, we cannot find the slope there. And then we'd start back here, flatten out is fine, and going up is fine. So we would have those 3 x values where we could not find the slope at those values. Number 2, slightly different wording, use the graph in order to determine all values of x in the interval from -9 to 9 where the function is continuous, but it's not differentiable. It's got to be continuous. So if we start here at -9, here is a discontinuity at -7, but it says where it is continuous, so we're not going to pick that one. Then I would keep going. This is a problem because that's a corner. So we talked about if I were to draw tangent lines from the left, see how this line would be negative slope, but if I come from the right, that's positive slope. So at -5, there's a corner or a cusp, and it's not going to have a slope there. And then I'd keep going, 0 is fine. Keep going, negative slope, 0 is fine. Keep going, at 2 is another corner or cusp. Keep going, 0 is fine. Here's a hole, but that's a discontinuity, so that's okay. And then we'd have 0, and then that's it. So really you're only looking for where is there a corner or cusp, or where would there have been a vertical tangent line, and I did not see any. So those would be our only 2 problem areas.